Alright, this is lesson 2.3.2, solving compound linear inequalities. As always, if you are confused or you missed something, if you're falling behind, please pause the video, rewind it, play it back as many times as you need to. Don't feel like you have to catch up or keep the same pace that I'm moving. So pause it as many times as you need to. Otherwise, we're going to jump right into this. Alright, so solving compound linear inequalities as the learning target, and then just as we did before, we will also graph them. Okay. Compound inequalities, these are just basically a special type of inequality. You're taking two different pieces and you're going to put it together using the words and or. As far as solving them, we can use similar procedures as we used with basic inequalities. Remember your number one rule. Flip the inequality sign when you're multiplying and dividing by a negative. The differences are going to happen when we actually graph the solution set. So since we're solving what is essentially two inequalities, we're actually going to have a solution set which is between two values or in the opposite direction of two values. Okay, so the solution set's going to look a little different from what we've had previously. To give you an idea of what that looks like, take a look at this little chart here. So these first inequalities, these are examples of and inequalities. You will literally see the word and written, or you will see it combined like so. So if you see it written with the word and, you're literally just reading it as it is. So x is greater than or equal to -4 and x is less than 3. When they have it combined like this, if you start in the middle, look to the left, x is greater than or equal to -4, look to the right, less than or equal to 3. Those are the two different notations that you will see. The bottom one is probably the most common, but they mean the same thing. To give you an idea what that looks like, just do one at a time and go from there. So x is greater than or equal to -4. This guy is going to get a solid dot. Okay. If we're going to say greater than, we would shade in the right direction. I'm only going to do that little piece for the time being. And then less than or equal to 3. Less than or equal to 3. And less than would be to the left. So as you can see, what's going to happen is you're going to run into the same shaded area, and your solution set's going to be between these two values. Okay, so that is an example of an and inequality. An or inequality has one option. You will literally just see it with or written in there. That's the only way that you can have it. This one you have x is less than -4 or x is greater than 3. So same idea here. Plot one at a time. Less than -4, open circle, shade this guy to the left. X is greater than or equal to 3. Greater than or equal to, solid dot, greater than, and we're going to shade to the right. So as you can see, there's this portion in the middle that is not shaded. That value, or those values, are basically representing values that don't work. Okay, so your solution is going to be to the right and to the left. If you can keep in mind that and inequalities will be between two values, or inequalities will be in opposite directions, keep that premise straight, then you'll be able to handle as we go. Okay, so let's take a look at how to solve these things. Okay, when you have something that looks like A, in the middle is what we're going to focus on. So we have x minus 3 is greater than -5. X minus 3 is less than or equal to 1. Okay, so typically when we solved these before, we only had one side of this. Okay, so say we were solving the side with the 1. We would take 3, add that. When you have something that is a compound inequality like this, if you do it to the right side, you also have to do it to the left. Okay, so you can actually take an inequality and solve both at the same time. The right will become 4. The left will become -2, and then your solution is already finished and ready to plot. If you want to, you could take the inequality. If you take x minus 3 is less than or equal to 1, you could break it up and then make two separate inequalities and solve them one at a time and then go from there. The helpful thing when you keep them together is that your solution is already there, and then you can just look at it. Since it's an and inequality, you know you're going to shade in the middle, so it's a little easier to keep it compact like that. Other than that, let's go ahead and plot it. So x is greater than -2, greater than, open circle, less than or equal to 4. Since it is equal to, we want to include that value in and inequality, shade in the middle, and it's done. Okay? So you have a sliver of your number line that is being included. Let's go ahead to B. B, we have 2x is greater than or equal to -2. 2x is less than 8. So normally we would solve this by division. Okay, since we're doing it on the right, we also have to do it on the left. So that will give us the middle portion will be x, which is what we want, 8 divided by 2, -2 divided by 2, and it's done. So your solution is ready to go, ready to plot. X is greater than or equal to -1. X is less than 4, open circle, and inequality, shade that in the middle, and it's finished, okay? So when you solve them simultaneously, do everything on the right, do everything on the left, keep it going, okay? So even when we look at something like C and D, these look a little more difficult, but in reality, they're just two-step inequalities. So let's get this 6 out of the way first. Okay, on the right and the left, the middle is going to become just a 2x. We get an 8 on the right. On the left, we get a 2. And divide by 2, get that x by itself. The middle gives us x by itself. The right side becomes 4. The left side becomes 1. And that guy's finished. We're ready to plot, ready to go. So let's plot it. X is greater than 1. X is less than 4. Open circle on both. And inequality, shade in the middle. That guy's done. Okay, last one. -6x plus 4 in the middle. Let's get that 4 out of the way first. Okay, we're left with -6x in the middle. On the right, we get -24. On the left, -30. Okay, this is really the only tricky part that you have to watch out for is when you have these negatives and you're going to be dividing. So we have to divide by -6. When we do that, the middle becomes x, which is what we want. Division by a negative, we have to flip the sign and then divide. So we get 4 over here, flip the sign, get 5 on this side. Okay, and that's finished. So we flip the sign because of the negatives. Now if we look at this, we're saying x is less than 5 and greater than 4. While we could plot that as it is, typically you're going to see the smallest value on the left and then the larger value on the right. So if you reverse the order, make the mirror image and get the following. X is greater than 4 and less than 5. That's typically how you're going to see it written. You could still plot it. Either way, we'll end up with the same thing. Okay. Open circles at both 4 and 5, shade in the middle. Your solution is that tiny little piece between those two values. Okay. Alright, if you've missed any of that or if that was a little too quick, please go back. Otherwise, we're going to go on to OR inequalities. So, OR inequalities, these will look a little easier because these are just basic linear inequalities and you're just solving 2 of them. That's literally all that's happening. Okay. So, x minus 1 is less than or equal to 1, or 3x is greater than or equal to 12. So, solve one at a time, and then plot your solution one at a time. So, this guy, let's add the 1. So then we get x is less than or equal to 2, or divide by 3, get greater than or equal to 4. Okay, same thing here. Or inequalities will go in opposite directions, so when we plot this, we should go in opposite directions. If not, then that's a problem. So, less than or equal to 2, equal to, shade to the left, greater than or equal to 4, solid dot, greater than, we're going to go to the right, and that guy's finished. Opposite direction, the piece in the middle is not a solution. Alright, let's keep it moving. -6x less than or equal to 18. Hopefully, you notice that you're divided by negative, so hopefully you're a step ahead of me and realize you're going to have to flip that sign. Over here, let's subtract the 5. Let's get x is less than negative 4. Okay, so once again, do one at a time. X is greater than or equal to negative 3. Solid dot. Greater than, we're going to the right. X is less than negative 4. Less than, we're going to keep an open circle. Less than, we're going to go to the left. So this little tiny region in between those two values is not a solution. Everything to the right and to the left will be. There you go. Alright, so just as with other inequalities, you can make it as complicated as you want. Take a look at G. So G, we have two-step inequalities. Don't let something like this intimidate you. Just keep to the basics. Get the x by itself. So let's move that 6 first. Subtract the 6. Divide the 4. We get x is greater than 2. Same thing here. Two-step equation, or inequality. And then we get 5x is less than negative 15. Divide x is less than negative 3. And we're good to go. So x is greater than 2. Open circle. Greater than. Less than negative 3. Open circle. Less than. There you go. Piece in the middle. It's not going to work. Everything to the right and the left will. Last one. 3 minus 2x is less than negative 5. Let's get this 3 out of the way first. Okay. When we drop this down, don't forget to include the negative with that 2. Okay, and then we're going to end up with negative 8. Dividing by this negative is going to turn this sign around, so we no longer have less than. It is now greater than 4. That guy's done. Over here, add the 2. 2x is less than negative 6. Divide by 2. X is less than negative 3. Okay, so we have x is greater than 4 or x is less than negative 3. Let's plot these. Open circle. Go to the right. Open circle at negative 3. Go to the left. Once again, or inequalities, opposite directions, and that's finished. Alright. If you need more practice, we're going to go back and do the pause and try these section. Okay. Otherwise, if you feel comfortable enough to move on, please try numbers 1 through 4 at the bottom of the page. There are number line located at the bottom, and you can plot right there. Alright, if you're going to stick around, let's take a look at these pause and try these sections. So if you want to, for the moment, pause it, take a couple minutes, try these two, come back and see what you get. Alright, hopefully you've paused and tried them on your own, so let's take a look and see what happens. So this first one, we're going to subtract the 2 first. We have an and inequality. We're going to get 6x left in the middle, we got a 6 on the right, and then we have a negative 12 on the left. Last step here, divide by 6. Get that x in the middle, which is what we want. On the left, we get negative 2. So we're between negative 2 and then less than or equal to 1. Negative 2 is going to get an open circle. 1 gets a closed. And inequality, shade in the middle. That guy's done. Okay, this one over here. Add the 3 first. 4x is less than negative 16. Divide by 4. We get x is less than negative 4 over here. Subtract the 2. We get 6x is greater than 24. Divide by 6. X is greater than 4. Last thing we got to do, plot these at negative 4, open circle, less than, going to the left. At 4, open circle, greater than, going to the right. Everything in between them, including the values, is not going to work. And there we go. So, as always, if you missed anything, please rewind it back, play it back as many times as you need to. Otherwise, if you are still with me, and try these 4 right here at the bottom, plot on a number line, and show your work on a separate sheet of paper. Alright, I will see you tomorrow.